Okay, so what we're doing is we're kind of taking a step back and we're going to review some of these area formulas, okay, before we get into what the book has. So the learning targets solve problems using the area of rectangles, parallelograms, and composite figures, and use coordinates to compute perimeters and area of figures. All right, so we're just remember that the area of a rectangle is base times height. So it says the picture below represents a countertop. The countertop costs $8.50 per square foot. Calculate the area and the cost. All right, so your best bet for this is to kind of draw like a little line either here or the other side. It doesn't matter which one you choose, but you're going to calculate each area. So the area of this is going to be base times height. So that's 2 times 3, which gives us a total of 6 feet squared. And this rectangle in orange is going to be 6 times 2, which gives us 12 feet squared. Add these up. That leaves you with a total of 18 square feet. Now, the big thing here is that they want you to find the cost. So this is $8.50 per square foot, which means we don't have to do any conversions. We're just going to take the 18 and multiply that by the $8.50, which will give us the total cost. Now, someone tell me, what is that going to be? What'd you get? It's more than that. 18 times $8.50. So it's 18 times 8.5. Should be a lot more than that. Yes. Yep, $153 even. Okay? Does that make sense? Questions? Anything? All right. Example 2, given the 2 rectangles below, find the area of the shaded region. All right, so your first step. Are we okay? I read it wrong because I read it as 15 point when it was actually 153. So I was like, I just said. You're okay. Don't sweat it. All right, guys, let's go over this. So the first thing we're going to do is we're going to find the area of the big rectangle, square, whatever this is, okay? So if we have 7 plus 5 here, we know that this total side is 12. And then 6 plus 5 gives us 11. So this is actually a rectangle. So we're going to find the area of this first. So this will be 11 times 12. Someone tell me, what is 11 times 12? Good. 132. So it's 132, I would put units squared in case they don't give it to you, because they really didn't here. Okay, so now what we're going to do is, now we're going to find the area of this small part, all right? And that was 7 here. So the area of the small figure is going to be 6 times 7, which leaves us with 42, and that'll be units squared. Now, in order to find what that shaded area is, we're going to take the area of the big, subtract that from the area of the small rectangle, which gives us 132 minus 42. And what's 132 minus 42? 90. So this will be 90 units squared. Questions on that? Okay. It says one rectangle is framed within another. Find the area of the shaded region of the frame is 1 unit wide. If the frame is 1 unit wide. Okay. So we have 9 and we have 6 here. Now here's what you need to do. You need to find the lengths of the smaller parts. We know that there's a unit here, a unit here, here, and here, but also here, 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 and here. So if this whole thing is 9, this is essentially 9 minus 2. And I should probably make that in yellow because it's not. So this will be 9 minus 2 here. And this side's going to be 6 minus 2. So the smaller rectangle is going to be 7 by 4. Does that make sense where that's coming from? Okay, so this is the small one. So again, let's find the area of the big one. That's 9 times 6, which gives us a total of what? What's 9 times 6? What'd you say? 54. And then we're going to do, let me get a different color. Area of the small part, which is 7 times 4, which is what? 7 times 4 is 28. Now here's my question. Did I really need to even find the area of the big one? Because area of the shaded region, right? So did I have to do it that way? No. So after looking at this a little more closely, all I needed was this part. But it's not a bad idea to have more practice. Questions? Okay. All right, so this says, a diagram showing a rectangular tabletop is plotted on the coordinate plane. Find the area of the perimeter of the rectangle. Okay, so now this one's very easy because of the fact that we can just count and get the amount of units we have. However, if it's ever like tilted, you're gonna have to use the distance formula. So let's if figure is tilted, use distance formula. Okay. So in this case, we're going to find this. So I'm just going to count 1, 2, this is 3 units. And then we have 1, 2, 3, 4, 5, 6, 7 units. Okay, so for the area, we're going to have 3 times 7, which equals 21 units squared. For the perimeter, we're going to add all these sides together. And it doesn't matter the shape, it's just add all sides. So 3 plus 3 plus 7 plus 7 leaves you with a total of 20 units. Perimeter is not units squared because you're adding it. You only square the units if you multiply. Question? Questions? All right, so that takes care of rectangles. Anybody still writing before I erase? Because it's dragging. Okay. Let's take a look at area of parallelograms. Now, the area of a parallelogram is the same as a rectangle. It's base times height. Oh my gosh. Base times height. So basically what they're saying here is if I took this little part right here and I put it over here, you would have a rectangle. So that's why it shares the same formula. Okay. So for this one, it says find the perimeter and area of the parallelogram. So here's my base, 7. So area equals 7 times, now my height is 4. So that leaves me with 28 units. Perimeter, though, you're not going to be able to use this height. You have to use the 5 here. So this will be 5 plus 5 plus 7 plus 7. Should leave you with 24. Oh, sorry, that's units squared, my fault. And this will be 24 units. Try the next one on your own. Find the area and the perimeter. All right, anybody still working on this? Who's got the area? Anybody? Bueller? Who's got the area? Giano, what's the area? Very good. 126 units squared. Who has the perimeter? Evelyn. Yeah. Remember, that is units. Okay. Now for this next one. Actually, these next two. I want you to at least plot these two. Okay. We'll go over this one in a minute. But plot both of these. I'm going to give you a few minutes to do that. Okay. Go ahead. Plot them first. Okay, guys. So if we plotted this, you should have something like this. Let's see. -3 up to 4. So there's F, G, 2, 2, H, 2, -4, and J, -3, -2. So here is our graph. And yes, on your test, you will have to graph these. So draw the parallelogram, determine the perimeter of the parallelogram to the nearest tenth. Okay, you have some options here. This is easy. We can count this. 1, 2, 3, 4, 5. There's 6. Okay, so we know this is 6 and we know this is 6. Your options are the following. You can apply the distance formula here. That's one option. The second option is you can apply Pythagorean theorem by just dropping to get the height. So if I kind of drop that right there, I have a height here of, let's see, 1, 2, 3, 4. I have 5. That easily gets me the area. So the area is going to be 6 times 5, which gives me a total of 30 units. Now you can apply distance formula, or you know that's 5. This little part right here is 2. You can find this using the Pythagorean theorem. That's another way. So this would be 5 squared plus 2 squared equals x squared. This will be 25 plus 4. So this is 29 x squared. And then take the square root. What does x equal to? What do we get? What's the square root of 29 in your calculator? Round it to like the 10th. What do we get? Connor, what do we get? 5.4. Very good. All right, so now that we have that, we know that the perimeter will equal 6 plus 6 plus 5.4 plus 5.4. So that's 10.8 plus 12. So is that 22.8? And this would just be units. Questions on that? All right, try the next one on your own now that you have it plotted, and I'll show you guys the solution, but give it a shot first, okay? Same process as up above.
No, that was what she said. I'm thinking about it. No, that's fine. Because you don't have to. That was nice.
So your hands are still working on this one. Okie dokie. So I'm going to show you the solution. Let me know if you have any questions. I wish I could make this a little better. That's the best I can do right there. So remember, just graph it first. Remember, the height is always going to be perpendicular. That's like the big key there. And then in order to find this angle, the easiest way is to apply Pythagorean theorem. Any questions? Anybody need anything on this at all before I have you guys do homework? All right. Homework's on delta. Those of you watching at home, have a great day.